Hey, how's it going, guys? So back here at the Python BACnet Stacks playground, just yeah. So basically, this is just a place to be super exploratory, let your mind wander, be creative as possible. So we've been doing a lot of cool stuff on like studying the BACnet stack scripts, making using the Python network stack for backpipes 3, back 0 is another one, how to interact with building automation systems, exploring OpenClaw, some AI stuff, the Codex CLI, that's another one. So yeah, lots of exploratory things going on, and so right now we'll probably be stuck on fault detection for a while. So this is something also, there's AI generated mini lessons for daily challenges. I've been so strapped on time that I've been having a hard time getting to these, but it's really good. Like if you're someone like building automation, like an OT skill set for operations technology background, and you never had computer science coursework, like myself, there's AI generated mini lessons for the bare basics, just syntax in Python, and then kind of getting up to operators and math equations, and then getting into really simple data structures and algorithms. So like I think I got all the way up to day 30 in the AI generated just an AI generated mini challenges where you just kind of work through some really basic Python. You can kind of take like a month or a lunch break a day kind of a thing. It's what it's meant to. It's like, I did think YouTube recorded up through algorithms where it does get kind of hard. I will admit I have to cheat a little bit with AI a little bit. And some of the algorithms can get really complicated in computer science theory. But I don't think we have to go into like super high level algorithms studying to be to know what we're doing in the HVAC world, because it is kind of like real basic stuff. Like theoretical computer science algorithms can be like way complicated, way more than what we need to be doing here. So I kind of like just like focusing on, so I'll probably never venture out of the little HVAC silo world that I've been working in for the rest of my life. I think I'm locked in it for good. So I probably won't study something that's not applicable to it. You can study fault detection equations. We're going to be doing this actually today. Probably all week actually, but there's in the AI generated mini lessons, week 6, if you're interested in kind of brushing up. And then there's also guideline 36 in here as well. So this is something I vibe coded also on YouTube about a year ago in Java for how to do guideline 36 in program objects. So there's also Python based mini lessons for how to do zone requests, air handling unit duct static pressure resets, chiller plant resets. Kind of cool stuff. I'll definitely be coming back to that, especially the chilled water guideline 36. I haven't implemented this in the field yet, but I have implemented lots of the air handling unit VAV systems, probably about 30 or 40 air handlers in Java land in the Niagara system in one hot water plant. That is kind of cool. So the hot water plant trim and respond is generated from air handling unit requests for heat, and then it resets the chiller or the boiler plant hot water set point. It's kind of cool. It's working. No complaints on the building yet. And then also, I hope to get into the guideline 36 chiller plant. So you're basically resetting the pumping differential pressure and also the chilled water temperature set point. So yeah, pretty cool stuff here. And then also, we're going to be getting into this. I have a feeling we're just going to be vibe coding a lot of this, but there are, this gets into advanced data structures. So this is, I'm guessing, I think it's more like master's degree level computer science theory. So advanced data structures, graph theory, which is related to smart building data modeling, like brick and haystack and 223p. So this is something I need to study myself, is how you get the theoretical background for RDF, which is the resource description framework that runs behind a lot of this smart building data modeling. So the computer science people, like the PhD computer science people that somehow migrated into the HVAC world, they're the ones that brought this to the HVAC world for us to use. So it's all graph theory, RDF lib and Python, and what kind of advanced data structures you need to study to be just focused on this. Because I think this can be a super broad topic as well for advanced data structures. We're probably in the smart building industry. We probably only need to study just like a teeny little bit. So it's kind of what this is attempting to do. So right now we're up to SparkQL. So that's the query language for brick models. AI is really good at writing these. So 75 days of mini lessons, all the way up from BACnet to advanced data modeling exercises. So, and they're all mini lessons generated by AI, which I'm a big fan of it too. Like I think ChatGPT or any of them is really good at write me a mini challenge for how to know something. And it's really good for computer science theory stuff. Okay, so enough about this. I'm kind of on a limited time crunch. So coming up, we're also going to play around with some chips, some embedded device. So STM32, they call it bare metal. So right now we're only playing around with embedded Linux, Raspberry Pis, and also the Ubuntu server Linux. So let's get into that. That's coming. The BACnet stack in Rust, created by Justin. So it's coming. There's just so much to do. And after the fault detection, which might be another week or two, I was like, I want to do something in BACnet routing. So this will be further down the line, where BACnet routing can be a nightmare if you have a campus environment and there's multiple vendors. I've seen this before, where a higher education campus, where Train has one building, and then Siemens has another building, and JCI has 3 other buildings, and it's one flat IT network, and they're all communicating on different UDP ports, and it makes an integration nightmare. So that's something we'll study, how to handle that. And then I'm also dying to just this will be something way exploratory for me. It's really close to, I have a feeling that this might be bumped after this one. So this is like, once we study a little bit about BACnet routing and what BACpipes 3 has to offer in BACnet routing, I know some people have also expressed interest in how could you make a BACnet router from scratch with a Raspberry Pi. And I think enough pieces of enough tools are out there on the internet to possibly cobble something together in open source BACnet stacks with BACpipes, and then there's also a BACnet stack written in C for embedded systems that you would kind of queue into that would handle all of the BACnet MSTP, RS-45 stuff. So that goes like way out of my wheelhouse. So that's why there's just a playground to be, let your mind wander, be exploratory, learn a few things, and So right now, we're on AWS IoT Core, sending telemetry data from MQTT Secure to AWS Data Center. This is also really out of my wheelhouse, but I think we can dumb it down to, like we know HVAC, what is some really basic fault detection equations, and fault detection is another topic that some people specialize in that are like master's degree mechanical engineers. but they might have a different approach. But I do have enough experience in commissioning HVAC systems for 10 years as a field technician. I think I can give them a run for the money. So that's kind of like my background is I'm a field guy. I've been commissioning HVAC systems. I have been playing around with data quite a bit the last couple of years in programming in Python. So it's kind of combining a lot of those experiences together. So yeah, let's get into it. The codex thing of seeing if AI can build a building automation system, it's kind of on hold for now. I need to put this to inactive, but has a really basic. It did build a building automation system. It would take someone it has a huge library of these skills markdown files where we can maybe pick apart that a little bit later, but it has enough agentic AI model context to build a web app that can make a building automation system with everything we've studied prior to this, of vibe coding a front end in React, and then also with the BACnet drivers that we've been making. So we can make our own driver framework. So yeah. So if you're a person like me that has built building automation systems, why can't the auto mechanic build a car? They're perfectly qualified. There does get to be some software engineering skill sets where you have to have a whole security. There's the IT security. That's huge can of worms to know too. So that's I think this will be a really hot skill set. I'm just kind of my own opinion here that people that prompting is not hard to code the AI, but people that are people that have a building automation background, there's Linux certifications out there. Maybe someday I might get an IT certification in Linux, and then there's also another one in Security Plus. So yeah, I might do Security Plus certification, Linux Plus certification. There's also ones I've done a long time ago in the A Plus, which is just very basic computer IT certificate, and then Networking Plus is another one. So yeah, all really good stuff. I think all of that looks really good on resumes. Having a building automation field technician background, combining all of that together, and then all of the computer science theory stuff in Python. Yeah, it looks really good. Okay, so enough of this. We need to get into it. I got about a half an hour here. Okay, so we're on Vibecode app 12. So I have been yapping about this one for a while now. Okay, so I'm on the Windows computer, PowerShell. This is the same computer I'm recording this YouTube video in. And my little server here, I think I panned my camera before. This guy, hard to see. This guy right here is just a really old, cruddy desktop converted to Ubuntu Linux. So that's it's meant for servers. So it's a Linux server. There's no desktop environment, only command prompt, Linux Bash terminal. So that's what I'm hosting all of this from. Is I'm using the Python. This is where I clone everything now. Is on this Linux server. You could also do this on a Raspberry Pi as well. Except my Raspberry Pi collection, they're so old. They're like the Model 3 Plus, B Plus models. So they're maybe people with the modern Raspberry Pi 5s or whatever. It's too old for me to use cursor on these older ARM architectures, I guess. So, but what I can do is actually do all my work here and then use an IT automation tool called Ansible, and I can push. So Cursor is really good at writing the code, testing the code, and then I can instruct it to use an IT automation framework called Ansible, and it'll push code to the Raspberry Pis. I think other people use Ansible in IT for maintaining web apps. So they would have like a little local Linux. You could also do this on Windows with Windows Subsystem, WSL for Linux. But I have this thing laying around. So like you could use Ansible to be pushing Python updates and bootstrapping remote web apps if your work is on the internet. For me, my work is mostly on the building operations technology land. So like in theory, we could have 50 Raspberry Pis running in 50 different buildings, and then through a VPN to each building, we could be pushing updates to our Raspberry Pis. So I have that at the pipeline too. That's coming. Where someday there'll be, maybe I'll just do this now. There'll be, this will be future remote BAS. And then we're going to be actually talking to it through a VPN connection. So basically Ansible can push through a VPN and then also bootstrap this remote thing here too, and then we could be also ingesting that data to AWS IoT Core. And this is slick, this AWS IoT Core. I'm actually kind of impressed with this. So this was kind of like, okay, getting back up here. So I used this computer, which I SSH into from my Windows computer. I basically set up everything in Linux, including like testing everything that I can get MQTT data back and forth. So I think the AWS IoT Core has been really cool. So we're running Lambda functions here. So these are Python functions that are they're functions written in Python, where the Lambda feature is just, it wakes up the function whenever you need it to go. So that could be on an interval, that could be on a request, that could be on a, something. So it's usually an interval or a request. You can wake up the Lambda function and it can do things. A cron service. So someday I think we might have, I think right at the moment there's 3 Lambda functions, where one is hosting this flimsy web app that I have some ideas for that too. Another one is doing the fault detection, and then another Lambda function is collecting MQTT data. So right now this Raspberry Pi that's reading this temperature sensor data, one wired digital temperature sensor wired to the hardware on the Raspberry Pi. Every 10 seconds it's sending a payload to AWS IoT Core, and then there's one Lambda function that's listening to this MQTT topic that's then putting the data in the database, which is a Dynamo database, I guess, that AWS IoT uses. So yeah, pretty cool. So like right now Cursor is totally facilitating how to set up my AWS IoT instance. It zips up all the files, the configuration and everything, and then I actually download that again to Windows and I upload that. I think I demoed that on the last video, and then basically just reboots itself and then configures everything. So that's where we're at here. So this is a Lambda function. If we wanted to look at the code, I'll get to this in a second. I got 20 more minutes or so. Vibe code at 12. There's the Ansible playbooks are in here. Testing scripts for AWS IoT Core. So this is how you publish fake data. There's also .key and .pem files. So those are you download. It's a starter kit from AWS IoT. This isn't pushed to GitHub though. We don't push those to GitHub for security reasons. Not that it matters, but this is just my little test bench, so it doesn't matter if some bad actor gets my .key and .pem file, but that is like how the MQTT packet it gets encrypted from make it into MQTT secure. So it's encrypted data that isn't pushed to GitHub. So that's their testing scripts. Okay, so then this is the pipeline. So these are the Lambda functions here that maybe I'll be able to spend some time to go over this in more detail. I'm creating another expression rule cookbook for fault rules. So 3 Lambda functions, what I just talked about. One is the number cruncher for faults, where we write data back to the database. This is hosting the this is hosting the web app, and then this is listing the MQTT topic. So I think I just need to go, and then it's all deployed through SAM, AWS's serverless model application model. So this is, it orchestrates everything. So Cursor completely writes all of the configuration files for SAM, and then I just upload it as a zip file from my Windows computer. So Lambda functions, the DynamoDB, the IoT rules, in some kind of a YAML file. Pretty cool. And I'm getting this all for free, so it hasn't costed me money yet. And if anyone ever wants any help with this, I am doing a little bit of freelance work. So if you wanted to set this up in production, please reach out. There's also on here Discord. So ping me on Discord. There's other people online too that are really smart in this industry. Okay, so I'm going to close out of that. Enough with this. Okay, let's just jump into this. So right now there's just like something is going on. There is just boatloads of faults running. Faults. So like something is wrong. Blatantly, the famous in fault detection is there's false positives, and there's no way that there can be this many false positives. So something's wrong. So I have 4 faults running. One is an out of bounds fault, which we'll talk about in a minute. A flatline stuck sensor, and then this purple one, which appears to be a hassle, is a rate of change. So the sensor is changing too much per hour that it's throwing a fault. And then there's also a rate change per minute. So for whatever reason, this calculation is wrong. Okay, so this is just kind of a temporary little dashboard hosted by the Lambda function, which I think is totally fine for our little demonstration here, but I have some ideas where I might put this is coming, maybe even by the weekend, or the weekend is like we can put this in a like a dashboard that I can on my little server over here. I want to host this as a dashboard behind my firewall. It won't be even on the cloud, and then I can just dial into AWS remotely. That's what I'm shooting for, at least. Okay, so we're getting data. So it looks like I think something wrong. Might be wrong in timestamps. It's actually showing that maybe not though. Maybe we're just 2 hours behind. I mean, the data is almost near full real time. I just don't think that. Yeah, it says it's. Wow, that's really crazy. If it can update that like that, so 2:47 my local time, so it's real time data. That is kind of cool. I didn't realize it was that. we're publishing a lot of data. So if this was a live HVAC system, I probably wouldn't be publishing every 10 seconds. I might do 5 minutes, just or even 1 minute. I think would be plenty. But every 10 seconds is just an awful lot of data. But it's kind of fun for testing purposes. And it's near real time, which is really cool. I think this AWS IoT core is really neat. Okay, so this is what I've been building. So this is a way, there's ways to run Python, like it doesn't run in the browser like JavaScript does, but you can play with Python in the browser and then it sends it to the back end to be processed, because Python is not a, whoops, this is just some words I've been playing around with. So Python is not a like a program that can run in the browser. JavaScript does, HTML does, CSS does, but Python is like a back-end computing language. So, but like we can, there's lots of different frameworks that, and especially in data science, and some really, there's quite a few different places where you code Python in the browser, but then it's always processed on the back end. So we're stealing that. So basically, like we can add in a rule. Here I have an F string, so we covered F strings in our theory lecture. So we can just we can test this, and then we can see our print statements. So what this will do, this will send all of this to the back end, and then but we can still troubleshoot it. So it's processing all these rows of data all in 10-second intervals. And it looks like we only get to see 30 rows, I guess, up here. But this is all of them. 1,870 rows. A lot of data. And there's also something I forgot. It looks like something for the LLM. So you can copy things in here too. So this is what we'll be doing. We'll be playing around with Python and seeing if we can tune our rules. So I might only put this down to 1. So, okay, so what is this? This is a row of data. This is a function. We've been playing around with the functions a bit, and then there's a bunch of things that get passed into this function. So I want to see what this is. So there's a variable called F. So that stands for temperature. And then there's a config. So this where's our config? Maybe the config isn't on here. Let me just go back to the dashboard. So we have to look into this rate per hour. Oh yeah, here's our config. So for whatever reason, it looked like the config went away after we, there might be a little bit of bugs here. So basically this 65 and 80, that's a config. So this is, so if F, that's degrees Fahrenheit, if degrees Fahrenheit is less than our lower limit, which is 65, or greater than our upper limit, which is 80, that's a fault. Return true. There's also a print statement here, there too. So we could even put this. We could even do like a really high. Let's just throw a ton of faults for testing purposes. If it's not between 74 and 75 degrees Fahrenheit, throw some faults. Test the rule. Look at all those faults. Fault, fault, fault. So see down here, this is our print statement. And then this is something that we can copy, hit Control C, copy to the LLM if you want to. So this is really fun. You can play around with fault detection in the browser, and then this is running right on AWS. Put you back to 69 and 75. This is really typical comfort band in imperial units here. So like if the HVAC system is maintaining between 69 and 75, you know, that's not that bad. So we can test out our rule again. Ooh, and we're too cold. Lots of faults. Not by much though. So right now we're probably creating boatloads of false positives. So if I put 68, maybe we'll just do that. Test out our rule. So no faults. So for every timestamp, there's a fault. So for every timestamp, there's time step. Every timestamp, there is a Boolean rule equation that runs across there, and yeah, true or false. I think some other people in fault detection that might be like PhD computer science student or in mechanical engineering, you know, like you can get into more than just a Boolean true or false, but at least that's all I'm studying. I'd really be interested if anyone can let's improve this, you know, like I want to get into that too. I just haven't studied it enough. So this will be improving. We're going to be what we need to do at some point is to be able to install Python mathematic libraries like NumPy and Pandas to build data frames. It's coming down the road, you know, but now we're just, you know, like playing around with vanilla Python. So we tested our rule, and I think I can save this. And then if I go live, this is going to update the last 7 days in our database. Okay, so I want to drop down to flatline stuck sensor. So let's just look at this. Let's just test it out. What do we have here? So I think for this fault, there is, this is really cool. So test copy for the LLM. So like the LLM, if you copy all of this data, you copy it and then you could upload it to ChatGPT. ChatGPT gets to see the function, or Gemini or whatever, and it can help you write better code. AI is really, really good at computer science algorithms, and we just have to put our domain level expertise to the test. So let's just study this a little bit. Okay, so we passed into this function a row of data, the config. So our flatline tolerance here is 5/100th of a degree Fahrenheit. And then I think this window is time steps. So we could probably even print some data. So we covered this briefly in some of our early theory lectures. This is slicing through, this would be a list in Python, these brackets. So we're slicing a window of data, and then we're checking, so I minus the row plus 1. Yeah, maybe we'll just have to print, let's just put a print statement in here. We should be able to print an F string. So this is an F string, if you remember, and then we can inject a bunch of data in the F string. So let's just do W. I. And there's a win, whatever, a window, I think as a window. is this one called vals. I'm just trying to put some characters in here that makes it a little easier to view the print logs. Okay, let's test this rule. Okay, so what do we got here? Okay, so if you see this vals, this should be slicing some data. This should all be 10-second increments. That the MQTT data is coming up from the sensors. It's not changing much in this. So basically, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 of them. So that, I guess that's the window. I guess these prints are kind of big, hard to look at. Maybe there's too much data here. Well, let's see, what do we have? See if I can just zero in on like one. Okay, W equals 18, that's a window. I, 45. I equals 4, so this must be the 45th row. Maybe we should study this a little bit more. Okay, so we'll probably come back to this one, study it a little bit deeper. I just want to look for the one named win, so that's this variable. Row was, there might be even be a simpler way to write this too. Okay, so if we go down to the rate limit per hour, this is the one causing all of the issues. So let's just try this out. Okay, so we have an hour's worth of data here. It's a lot of data. Why is this causing so many faults? Is the equation wrong? Thinking. Okay, big plop of data up there. So I actually have to probably, I need to disconnect here for just a couple minutes, but I think we need to come back and then study some of these expressions a little bit and tune our faults. And then I think there's an easier way to study this. So like the basic nuts and bolts, if like the flatline sensor is that if the temperature does not change within this window of time, where for us 118, that would be 180 seconds, I guess. If the temperature does not change by this value, that's a flatline sensor fault. And obviously if this was like a static pressure sensor or something dependent on a fan or motor running, we would be filtering data for that as well. Checking the math again, so it looks solid, but measuring the wrong thing for the sensor stream. Okay, so the equation is not wrong. The fault logic is too noisy because it uses adjacent row specifics to compute the rate over a rolling window, such as 5 minutes, rather than every single sample. So we'll get into that later. That's something that's coming. They're covering rolling averages of data. So I think I have to end it for here, guys. But let's pick this up tomorrow. And then we can kind of chat a little bit about how to implement rolling windows of data. I just haven't got there yet. So if we go into Code app 12 and then into the AWS IoT pipeline, I think we'll get into this too. So expression rule cookbook. So we'll be building this. These are our simple. We studied this already, and then we'll be implementing a rolling window in raw Python. So this is coming. We'll just stay tuned. And then what we need to do is eventually do use like Pandas computing library and also the NumPy computing library. So I think we're kind of getting into some cool stuff here. So this is coming. 1 minute rolling average window. You code it. So we'll in here we'll be testing these out. So how to drop in a 1 minute rolling average to these readings, basically. So how to smooth out the data. All right, guys. So I have to run for today. So I think this is all for the moment. So so we'll be coming back to this quite a bit. There's a ton to study just in this alone, and then we can get to implementing it in more different computing libraries for math in Python. And then would be really, really cool is to like put this in a live building, which I have that kind of scoped out already as well. So yeah, please look me up if you're interested in trying this out. Scrape some data from your building, your BACnet system in AWS IoT core. So far, it's been completely free, and I have some ideas to keep it free, keep it going. So we'll talk to you guys tomorrow. Have a great day.